In this video, we are going to have a look at the various forecasting techniques that businesses use. So, what can forecasts be prepared for and why are they prepared? Well, they are prepared in order to see how much sales and how much output is likely going to be created within the future. We can also forecast our sales revenue figure. How much can we expect to actually sell within the next year or the next time period in order to see how much money we are going to generate into the business. We can also forecast any costs which we think may arise within the next time period. What is the purpose of it then? Well, it establishes realistic assumptions for the purposes of planning. It may be based on simple assumptions as well as some more complex ones. And it can also provide very reliable information if we are going to use a variety of methods and techniques. So the next question that we have to ask ourselves is, how do we calculate these? So the first way we can do this is by using the high-low method. So it is calculated in the same way as when we calculate our semi-variable costs. And it can be used as the straight line equation, which is as follows. Y equals A plus BX. Y would be our total semi-variable cost, whilst A is our fixed cost, and we would then add to that our variable cost multiplied by the number of units produced. Next up is linear regression. So if you want a more accurate representation, then linear regression should be used rather than the high-low method. So again, using this same equation of y equals A plus bx, y is going to be your dependent variable, A is going to be your intercept, b your gradient, and x your independent variable. So this can be shown on a graph, essentially. We then need to have a look and think about, if we draw the graph out, what kind of correlation are these going to have? So a perfect correlation for a business then is going to be if all pairs of values lie along the same line. A partial correlation, it's not an exact relationship, not everything sits on that line, but it is close enough to be an exact. The next one, what about if there's no correlation? This is when two values of variables are going to seem completely unconnected to one another. It is impossible to draw that line. So regression analysis then is going to assume that the perfect linear relationships, but this isn't always going to occur, which means that predictions cannot be relied upon. In this instance then, the correlation has to be measured. In order for a business to do this, they can use the Pearsonian correlation coefficient calculation. You may find this as being referred to as calculation R, which can be seen as follows. If you are using this calculation, it must always be between -1 and 1, because if R is equal to +1, there is a perfect positive linear relationship. If it is equal to -1, there is a perfect negative linear correlation. And if it's 0, there's simply just not one. So there are, of course, drawbacks then of using linear regression. Firstly, it ignores inflation entirely. It only measures the relationship between two variables, which of course means that there is an assumption that there is a direct relationship at all times with two variables. This is going to be nigh on impossible in most business scenarios. Also, it is only interpolated forecasts which are going to tend to be reliable. And it assumes that data in the future continues in the same path as what it has done in the past. This is unlikely, especially as we move in line with technology and the way the world goes. We are constantly in a state of advancement. After linear regression then, businesses may look to use time series analysis. So this is essentially a series of values for a variable which is going to change over time. If there are any seasonal variations, it is going to be measured at regular intervals across that time period. You may see this depicted as a histogram often. The components of this then, you may see T, which is the basic trend, S as being the seasonal variations, C as being the cyclical variations, and R as the residual variations. The main two that you should be aware of are the basic trend and the seasonal variations. So first, let's dive a bit deeper into looking at the basic trend. It is a long-term approach. It is the general direction of which the graph goes in, and it covers a long interval of time. Seasonal variations then are that of the short term. So short-term fluctuations in value due to different circumstances occurring at different intervals throughout the year. So an example would be that snow blankets are going to be highest in the winter for their sales. In the summer, you may see that ice cream is going to be in much more of a demand for customers to buy than what it's going to be in the colder winter months. Cyclical variations then, these are medium to long term, and essentially they are saying that there's going to be fluctuations in regards to the basic trend. It is rarely of a consistent length, and it will not always follow a similar pattern. It is usually going to be associated with the economy in terms of, is there a boom, is there a recession? Residual or random variations then, this is short term. So it tends to be due to irregular items, due to one-off events. So it might be due to a pandemic, a strike. It could even be to do with there has been a fire or a flood in the area. It's unpredictable, so therefore it does not play a part in any part of the forecasting because nobody would have guessed that that was going to happen. Residual then is the difference between the actual value and the figure predicted using this trend. Calculating the trend then. There are three methods that can be used to do this. Many businesses may use a combination of all three, whilst others may rely solely on one or two, or perhaps a combination of all of them. So inspection is the first one. This simply means that the business will draw out the graph and that line will be drawn by hand to the perfect fit. Moving averages. This will attempt to remove any seasonal or cyclical variation by the law of average. And the last one is the high-low method, or least squares regression, it may be called. In this situation, the x-axis is going to represent time and the period of time are going to be in numbers. So dealing with seasonal variations then, if they arise, there are two models which a business may use to implement when calculating these. We first have the additive model and then the multiplicative model. So that in the additive model, components are expressed as absolute values, which are going to be simply added together. Your seasonal variation is simply the difference between the trend and the original time series figure. Contrary, your multiplicative model is going to be expressed as a ratio, proportion, or percentage. You do your actual of your T multiplied by your S multiplied by your C multiplied by your R here. And the final thing that we're going to end this video on is by looking at the advantages and the disadvantages of using time series analysis. So beginning with the benefits then, forecasts are going to be very clearly understood based on the assumptions that have been given. This means that forecasting accuracy can possibly be improved with experience. Trend lines can then be reviewed after each successive time period. On the other hand, a big drawback is that there is an assumption that a straight line trend exists, which isn't always going to be the case. There is also an assumption that seasonal variations are going to remain constant. There is an assumption that whatever has happened in the past is a reliable guide to the future. Like I've previously said, it is not always going to be the case whereby what's happened in the past is going to happen in the future. Think about all the advancements in technology that are currently playing a big role in society. Look at the advancements in artificial intelligence as a big example to that.